Welcome to today's class. In today's physics class, we are going to look at work, energy, and power. So, the first thing, let us look at, we are going to start by looking at work. So, by definition, what is work? Work is as a product of force and the distance or displacement in direction of force, or the force should produce a distance or displacement. The unit for work is Joule, abbreviated as J. Since work is a product of force and the distance or displacement in direction of force, therefore the formula used to find work is force, F for force, multiply displacement. So force is measured in Newton and displacement should always be in meters. Okay? So let us look at an example. So example 1 reads, a man pushes a box along an incline by applying a force or by applying a 300 Newton force as shown. How much work is done? How much work is done by pushing the box? How much work is done by pushing the box? So we said work is a product of force and displacement. And displacement or distance should be in the same direction with the force, should be parallel. Now if you look at this incline, you have two distances. We have the horizontal one, this one, and we also have the vertical one, this one. And the force is going in this direction. Now, which one do we use to calculate work? Remember, it's a product of force and the distance. Distance and force, they should be in the same direction. But if you look at the distances that are given, we only have the horizontal one going in the opposite direction to the direction of the force, and the vertical one not in the same direction with force. And therefore, no distance given, the distances given, we cannot use them to calculate work. The distance that we are interested in is finding the distance that is in the same direction, or the distance that is in the same direction with force, this distance. So now here, we need to find the slant distance here. And this is the right angle triangle. And therefore we apply Pythagoras theorem for us to find the slant side. Okay? So if you apply Pythagoras theorem, a square plus b square is equals to c square. Let us make this one a and this one b, and there this one will be c. So a, 4 square plus 3 square is equals to c square. What we want to find is c. If we multiply 4 square is equals to 16 plus 3 square is equals to 9 is equals to c square. If we add these, we are going to find 25 is equals to c square. What we are interested in is to find c. If we apply the square root and also the other side the square root, we are going to find that c is equals to 5. So we get the positive value. So the distance that we are interested in is 5 meters. In finding work, we are going to use the distance which is 5 meters. So applying in the formula, we are going to have 300 Newton as a force, multiply the distance that is in the same direction with the force, the one we just calculated, which is 5 meters. And if you multiply, the answer is going to give us 1,500 Joule. So this is the work applied, or this is the work done by pushing the box. Okay, so that is how you calculate the work. Normally, if you are given an incline, you normally look for a distance that is slant, or the one that is going in the same direction with the force, not the vertical distance or the horizontal one. Okay, so let us look at the second example. The second example reads, a drum of water of weight 2000 Newton is lifted up a plank of length 2 meter onto a platform which is 0.8 meter high. So the height of the platform is 0.8 meter. But this drum of water is lifted up through the distance of 2 meter. So take note here, the distance is 2 meter, the slant one is 2 meter. What is the question? What is the work done on the drum against gravity? What is the work done on the drum against gravity? Okay, so remember, the distance should be in the direction of force. So this one was lifted up through the distance of 2 meter. And I did emphasize that if you are given a scenario where you are given an incline, you normally look for the slant distance, not the horizontal one, not the vertical one, but the slant one, because it's the one that is in the same direction with the force. Now here we are given the weight of the drum, and you know that weight is just some form of force. Okay, so correcting the data that we have here, we have the force, which is 2000 Newton, and we have the distance, which is 2 meter. Therefore, calculating work done against gravity, work is equals to the force multiplied displacement. What is the force? The force is 2000 Newton. You are multiplying with the distance, which is 2 meter. What is the answer here? The answer is 4000 joule. Okay, so that is the work done against gravity. So having looked at work, let us now look at energy. So what is energy? So energy is defined as the capacity to do work, or you can define it also as the ability to do work. That is energy. The SI unit of energy is joule. Okay, there are different types of energy, but in this topic we'll focus on mechanical energy. And there are two types of mechanical energy. That is potential energy and kinetic energy. Let us start with potential energy. What is potential energy? Abbreviated as PE. So potential energy is abbreviated as PE. So potential energy is the energy possessed by the body due to its position or configuration. That is how you define potential energy. But so potential energy due to position is called configuration potential energy, GPE, or simply PE. So what is the formula for potential energy? Since we said potential energy is abbreviated as PE, and therefore the formula that you use to calculate potential energy is mgh. What is M? So M in this formula stands for mass, and mass, take note, should always be in what? Kg. So if you are given the mass in any other units of mass, you need to convert it into kg before you multiply. Then G is acceleration due to gravity, and acceleration due to gravity on Earth is 10 meters per second. Okay, sometimes you use gravitational, that is gravitational field, which is 10 Newton per kg. Whichever you are given in a question, it will always be stated. So that is your G. What about H? So H in this formula is height, and the height is always in meter. This is the vertical distance. Okay? Now let us look at an example. So here is an example. A 20 kg object is raised to a height of 5 meters. What is its potential energy? So we have an object. If we are to draw a diagram, it's like this. Let us say an object is on the ground. Okay, it's on the ground here, and is raised to a height. This is the height of 5 meters. Let us say this distance is 6 meters. And of course, I'll add also this distance. Let's say it is let us put this one to be 4 meter. Okay, so an object of mass 20 kg is raised to a height, so on top there, okay, this is an object of mass 20 kg or 20 kg raised to a height of 5 meter and is moved along the 6 meter distance. What is its potential energy? Now take note, as we are looking at work, we used this distance, the one that is in this direction where the mass is being put. Okay? But this time around, if you are calculating potential, when you are calculating potential energy, you normally use the vertical height, this side. So applying the formula, potential energy is equals to mass, gravity times what? Height. In our case, the G, let us take our G to be, so G is given to be 10 Newton per kg. So what is its potential energy? So potential energy here is equals to mass is 20 multiply what is our gravity is 10 multiply what is our height 5. So you are going to have 20 multiplied by 10 multiplied by 5. We are going to have 1,000 joule as our potential energy. So this is how you simplify the potential energy. Okay, let us look at the second example. So here is the second example. A motor is raised to a motor used to pull a 10 kg. A motor used to pull a 10 kg box along a 5 meter incline. Okay, along a 5 meter long incline to the top of an incline as shown below. So this is an incline and a box, here is a box, okay, is raised to a height. So the height of the incline is 4 meter. We want to find the potential energy of the box here on top, because here the box is stationary, here it's not moving. So what is this potential energy here? So applying the formula, potential energy PE is equals to mass multiply gravity and height. So now gravity here, or G, is given as 10 Newton per kg. So replacing in the formula, what is our mass? So the mass of the box is 10 multiply gravity is 10 multiply what is our height? 4. So 10 multiplied by 10 multiplied by 4 to give us 400 joule as our potential energy. So that is how you simply calculate the potential energy. Another type of mechanical energy, which is kinetic energy. So what is kinetic energy? So kinetic energy is the energy possessed by the body due to its motion. So the body is moving. Remember, under kinetic energy or under potential energy, we said it's the energy possessed by the body that is not moving, or the body that is not in motion. But here kinetic energy has to do with it's the energy possessed by the body in motion. So what is the formula for kinetic energy? If the body is in motion, then it has velocity. So in finding kinetic energy, always there has to be velocity. So this is the formula that you apply when finding kinetic energy. So kinetic energy is abbreviated as KE, and of course you are going to multiply half mass, M is mass, and mass is in kg. Then V, velocity, velocity square. So velocity, it means velocity times velocity. Okay, so that is how, or this is the formula that you use to calculate kinetic energy. Okay, let us look at an example. So here is an example. A 2 kg stone is thrown with a velocity of 5 meters per second. What is its kinetic energy? So let us calculate the kinetic energy. Let us look at the data that you have. Okay? What is our mass? Because for us to calculate kinetic energy, the formula is Ke is equals to half mass and velocity square. What is our mass? Our mass is 2 kg. And what is our velocity? Is 5 meters per second. Applying in the formula, you're going to have half mass 2 v, which is velocity, 5 square. 2 and 2 cancels here. 5 square is 25 joule. So the kinetic energy in our case, or in this question, is 25 joule. So this is how you simply calculate the kinetic energy. For you to calculate the kinetic energy, you need to have the velocity and of course the mass. And take note that mass is direct proportion to kinetic energy, and also velocity is direct proportion. So which means as velocity increases, the kinetic energy of an object increases. So is the mass. Okay? Let us look at the second example. So a 600 gram stone is thrown with a velocity of 5 meters per second. What is its velocity? A 600 gram stone is thrown with a velocity of 5 meters per second. What is its kinetic energy? Okay? So in finding kinetic energy, you know that kinetic energy is Ke is equals to half mv square. So for us to calculate kinetic energy, for to look at the data that we need mass, of which we have is 600 gram, and we need also the velocity, of which we have is 5 meter per second. 5 meter per second. Okay? Can we now calculate kinetic energy? Remember, the mass is always, or the mass is supposed to be in kg. And therefore, we cannot calculate the kinetic energy because our mass, or the mass given, is in grams. So what we have to do? We need to convert the mass, which is given, into a kg. And the conversion is that 1 kg is equals to 1,000 of grams. What about 600 gram? We don't know. So if we are to cross multiply, we are going to have 600 gram kg is equals to 1,000 gram x. Finding the value of x, we divide also the other side gram. Okay? So what is our x? X, the value of x is equals to 600 divide 1,000, you're going to have 0.6 kg. So this is the mass that we are using. Okay? Now let us apply it in the formula so that we can find the kinetic energy. So now, kinetic energy, Ke, is equals to half mv square. We have the mass, which is 0.6 kg, half here. We have velocity, which is 5 square. Okay? So this one, 2 into that one, we are going to have 0.3 multiply 25. So the answer is 7.5 joule. So since we've looked at potential energy and kinetic energy, let us look at the conservation of energy, the interconversion that occur between kinetic and potential energy. Okay, so this is called energy conservation. Now, what does the law of energy conservation state? The law of energy conservation states that energy can neither be created nor destroyed, but can only be converted from one form to another. That is what the law of conservation of energy states. And in this lesson, we are going to look at the interconversion that occur between potential energy and kinetic energy. Okay, so let us look at the interconversion. So when you have a stone that is freely falling off the cliff, so the scenario that we have here, we have a stone falling freely off the cliff. Okay, so that is what is its potential energy on top there. So when you look at energy conservation, we are looking at what is happening between potential energy and kinetic energy. Remember, potential energy is the energy possessed by the body due to its position. Okay, and potential energy due to height is called configuration potential energy. On top of the cliff, this stone on top of the cliff there, it possesses the potential energy. So the kind of energy that the stone possesses there is potential energy. And in some questions you might even be asked, what kind of energy does the object or maybe the stone possess in the case is on top of a cliff? And the kind of energy is potential energy, because the stone there is not moving. So all the energy is in form of potential energy, no any other form. All the form of energy that the stone possesses there is in form of potential energy. And therefore, for us to find the energy that the body possesses at that point, we calculate the potential energy. And in calculating the potential energy, let us take our G to be 10 Newton per kg. What is the potential energy of the stone there on top? And bear in mind that the height is 10 meters. So the height of the cliff is 10 meters here. So the potential energy is going to be 20 multiplied by 10 multiplied by 10. And in this case, the energy there is 2000 joule. So all the energy is in form of potential energy. And on top there, the potential energy is 2000 joule. Now, when this stone starts falling, okay, when it starts falling there, the energy, the potential energy now starts being converted from potential energy to kinetic energy. So I said all the energy there on top is potential energy, and the total energy we said is 2000. But as it enters the motion, it's no longer possessing potential energy, as in the total energy is no longer potential energy. Instead, the potential energy is being converted to kinetic energy. Remember, we are looking at energy conservation. So the potential energy, as the stone starts falling, is reducing. On the other hand, the kinetic energy is what? Increasing. Okay? When it reaches the middle part of the height, okay, the midway of falling, that is, the height is 10 meters. So when it falls 5 meters and remaining with 5 meters here, the mid part here, the potential energy is equals to kinetic energy. All in all, potential energy is decreasing, kinetic energy is what? Increasing. So since we are saying 2000 is the energy, the total energy on top there. So which means at this point, potential energy is equals to 1000 joule, and kinetic energy is equals to, kinetic energy is still also 1000 joule. Total energy has to be 2000. Remember, energy can never be created nor destroyed, but only converted from one form to another. And as the stone is falling, take note that also its speed is increasing. So velocity is also increasing. Before the stone strikes the ground, okay? Before the stone strikes the ground, it has the maximum speed at this point. At this point, before the stone strikes the ground, it has the maximum velocity. So maximum velocity. It has the highest speed there. And all the potential energy here is equals to 0, which means kinetic energy is equals to 2000. All the potential energy has been converted to kinetic energy. Okay? So this is the KE, kinetic energy. So all the potential energy has been converted to kinetic energy. So that is the energy conservation that occur. On top of the cliff there, the total energy is equals to potential energy, but as the stones start falling, the potential energy is being converted to kinetic energy. That to say, potential energy is decreasing, kinetic energy is increasing. When it reaches the halfway of its falling, that is the middle of the height, the potential energy is equals to kinetic energy. But as it continues falling, okay, the potential energy continues decreasing until when the stone reaches the point immediately before it touches the ground or strikes the ground, all the potential energy has been converted to kinetic energy. And at that particular point, you have 0 potential energy. Okay? So that is what you need to take note. Let us look at now the example. So let us look at this example coming from 2020 ECZ school certificate. So the question is coming from, that is question 4 from 2020 ECZ school certificate, and the question reads: Figure 4B1 shows figure B 4.1 below is a diagram showing a stone of mass 2 kg that was pushed up from Q. So the stone was pushed from Q to R. This is the stone, so it was from the ground here and it was pushed, this is Q, up to R there. Okay? Then we have this midpoint, which is S. So at the midpoint of this height that we do not know is S. And down here, the bottom part is T. Now, what is the question? Find the potential energy of the stone at R. So find the potential energy of a stone at R. Here on top, what is the potential energy of the stone? So now, how do you find the potential energy of the stone here at this point? So we are given, what we are given in the question is work that was done. The work that was done is 72 joule. How do we find the potential energy? You need to know that when air resistance is ignored, remember this, when air resistance is ignored, potential energy is equals to work done. And therefore, the answer here is 72 joule. So the potential energy is equals to work done. So the work that was done on moving the stone from Q to R is 72 joule, and therefore that is its potential energy. Then the second question is, if the stone falls through RT, so if it falls through RT, that is here, if it falls through RT, this side, okay, what is its potential energy? What would be its potential energy at S? So remember, S is at the midpoint of its falling. So what is the potential energy at that point? And the question is just a mark. So at this point, when we are looking at energy conservation, we said potential energy at a midpoint of its falling, that is midpoint of the height, potential energy is equals to kinetic energy. And on top here, potential energy, all the energy of a stone is in form of potential energy. That is the total energy. And it is the potential energy that conveyed to kinetic energy. But at its midpoint of its falling, potential energy is equals to kinetic energy. There was 36 joule. The other question is calculate the height RT. So R is here, T is down here. Want to calculate the height of the slope. Okay? So what is the height? How do we find the height? Okay? So the only way we can find the height is when we apply the formula for potential energy. Remember, in the formula potential energy, there's height. So potential energy is equals to mass, gravity, height. So there's height here. So we can find height given potential energy, mass, and gravity. Okay? So let us take, in our case, gravity or G was given as so our G is 10 Newton per kg. So we can calculate the potential energy, or we can calculate the height. The potential energy is 72, the mass is 2, multiply the gravity 10, and the height, the one that we don't know. So we are going to have 72 is equals to 20 height. Okay? We want to find the height. So finding the height, we are saying 72 is equals to 20. If you make the subject, if leaving h alone there, we are going to have h is equals to 72 divide 20 is 3.6 meter. So our height is 3.6 meter. So that is how you find the height, and you can see the calculations that are involved, and this is the reason why the question was given a 2 marks. Okay? What about the last one? Find the velocity of a stone just before it strikes the ground. So in finding the velocity here, you need to know that as the stone reaches, before it strikes the ground, all the potential energy has been converted to kinetic energy. Therefore, the total energy is equals to kinetic energy. Okay? So, kinetic energy is equals to half mass V square. What is the kinetic energy? 72 is equals to half. What is the mass? 2. V. What is velocity? It's the one that we don't know.